And here we go. This is the diagram of each part of the instrument cluster, and we'll see all the gauges connected. Also we're seeing the odometer here, and there is a board which we took out. Is one of these boards, probably this one. Okay, so this goes and shows the blown out view of the instrument cluster. Okay guys, so we have already troubleshooted the odometer, which seems like working fine, but we highly suspect our stepper motor, but we cannot say for sure unless we go further to troubleshoot whether our board is doing what it's supposed to do and getting all the signals and providing all this signals to the motor and everything. If we look closely to this board, apart from all the bulbs we have and transistors and capacitors and resistors and Zener diodes, we see there's a chip integrated circuit. I'm not sure whether I'll be able to focus on it. I'm not very good at the cameras. But you have to trust me that it's what it's saying is it's a Toshiba, and the number is TD6330BP, Japan. This is actually I was able to find on internet with the data sheet for this chip, and I found out that it is what we should be expecting. It's a stepper motor driver. Here you go, and that's good that we get all the features to trace its pins. There is it. This is actually there is a phase 1, 2, 3, 4, and VCC, other specs in here, which is going to help us to identify whether this driver is working and getting all the voltage and signals, and there's no component failure in that. And what I did also is to map the whole board. As you see, this is the front and this is the back, and it's kind of easy board. If you just have time, you can check the continuity of each point, including the screen socket, because all major signals are coming through this green socket. I was able to check the continuity between the link between this stepper motor connector, 6-pin connector, and this stepper motor driver, and things look fine, but unless we power it up, we won't be able to confirm whether it's working fine. What I have done to check all the points, I have traced all the pins as much as I can and come up with this map, this schematic. This looks pretty sad, but here you go. This part is actually the stepper motor driver, and I was able to trace all the pins going from this connector. Let me take this out. There's a green connector here. I was able to trace all the pins, so I know which one is supplying the 12 volt battery voltage and ground, plus as you see there is a pin 8 is what is bringing in the VSS, the vehicle speed sensor signal, which is a 5 volt pulse. According to the spec is 0 to 5 volt pulse. And also there's a stepper motor connector, and I was able to trace all the pins to the actually speedometer driver, not speedometer, sorry, the odometer driver. But one interesting fact which I was able to find, which can help us a lot to determine whether this circuitry is working as it's supposed to be, and that is this line here, pin number 2, seems like going to this speedometer. Okay, this thing, the 3 pins which we see the holes on the board here, 1, 2, 3. These are the speedometer connector is providing 12 volt and ground, and one is the signal coming from this stepper motor driver. And I already in the beginning has mentioned that all other instruments in the cluster, those gauges are working fine. So if this since we know the speedometer is working fine, so this chip, this stepper motor driver must be working correctly. But unless we power up this board somehow, we won't be able to confirm whether our analysis is correct. And to power this board, we need a 12 volt power supply to replace the battery voltage, and I do have this 12 volt power supply, 2 amp 12 volt, plus one important thing is we need a VSS signal, which is a 5 volt pulse. I don't know exactly what frequency, but as faster the car goes, its frequency goes up. So we have to come up with somehow simulate that 5 volt pulse. And for that I have an idea, and I was able to design, and it's all over the internet. It's very simple to design a circuit which can generate a 5 volt pulse with a different frequency, different frequency which you can control to see whether. And what we're going to do is feed this pin 12 volt plus ground plus VSS signal, simulated signal, into the board and see what we're getting out of this stepper motor driver. And also we're gonna connect one of the stepper motor, the good one and the suspected one, to see whether it's rotating accordingly. Okay, so we'll go ahead and design a circuit which is gonna give us a pulse, 5 volt pulse with a different frequency. And here you go, I forgot to mention that I have this car electrical called troubleshooting manual, and from there I was able to find the VSS. This is a vehicle speed sensor signal coming in, and it's going to the pin 8 of the green connector, plus there is a ground on pin 9, and also it's showing odometer. I cannot, let's see if I can do something with it. There this odometer with this showing stepper motor. So pin 8 we're interested, pin 9 ground, and here you go pin 10, which is a 12-volt power supply. So that's how I was able to trace all the lines for the schematic which I created.